So the rest of the section is kind of geometry problems, and the first couple problems that we're about to do are going to be rectangle problems. We did some perimeter rectangle problems earlier this semester, and you should remember that when I create a rectangle, I make the shorter sides the width, the longer side the length. Not that big of a deal. Usually I make widths the variable W, lengths the variable L. In this section, in order to make squares come up in the problems, to make the problems need factoring, we're going to use the area formula for a rectangle. That is, the area is the length times the width of a rectangle. And we just jump into the problems, keeping this formula in my back pocket because I'm going to need it. So the rectangle problems that we solve now will solve a lot like the rectangle problems that we did earlier, and at least set up the same way. They'll solve differently, they'll set up the same way. So as I read through this first sentence, it says the length L of a rectangular bedroom is equals, and then 3 feet longer than its width. That's like 3 more than its width. This side right here, the longer than, is going to be a plus word, and it's a plus that switches the order, just like more is a plus that switches the order. This is really a grammar problem, at least this part of the sentence, and as you get higher in math, you're just going to have to figure out yourself what the words translate to in symbols, and you're not always going to have a table. So I tried to sneak this in here to make you think a little bit, even though I'm just telling you what it is right now. So it's a plus that switches. The 3 feet is going to go after the plus, and what goes before it is its width, and its width is going to be a W. So that first sentence, the length of a rectangular bedroom is 3 feet longer than its width, would give me this. The length is the width plus 3. And then the second sentence says the area A of the bedroom is equals 108. So the second sentence says area A equals 108. Somehow I need to fuse these two equations together, but they're not fusible the way they're written because they don't have any duplicate variables. So in that bottom equation, I'm going to change the area to length times width. So I'm going to, instead of saying area is 108, I'm going to say length times width is 108. And that will allow me to do the substitution that I'm ultimately going to need to do. I'm going to need to change the L in this equation to W plus 3. I'm going to need to clear the parentheses that I put in by going W times W and 3 times W. I need to set it equal to 0, and then I need to deal with that disgusting number that's probably not on my chart. So I've gotten through what I thought was going to be the hard part, but I made the number 108 part of this problem because so many times when I give word problems, students that are clever enough can get the answer just by looking at the problem and not really doing the algebra, because I try to make the numbers, tolerable. Here, the number's not so tolerable, and I'm paying for it now. So let me try to figure out the stupid negative 108. My table tells me I need factors that are positive and negative. Bigger number, positive. Yes. So let me do 108 divided by 2. So I can write negative 108 as 54 times negative 2. Let me take 108 and divide it by 3. I can write 108 as 636 times negative 3. We divide it by 4. I can write negative 108 as 27 times negative 3. 5 doesn't go into 108 because it doesn't end in a 5 or a 0. Let me divide by 6. Negative 108 equals 18 times negative 6. I don't think I can divide 108 by 7. Well, I can, but I get a fraction. How about 108 divided by 8? Get a fraction. 108 divided by 9. Ooh, that's a good one. 12 and negative 9. This is going to be the pair that I need. I needed the pair of numbers in this listing that if I add them, I get positive 3. And that's going to be 12 and negative 9. So with more work than I care to do, I can get this factored into w plus 12 times w minus 9. The w plus 12 parentheses would give me an answer of w equals to negative 12. The w minus 9 parentheses would give me an answer of w equals to 9. Unlike the number problems that we did with consecutive integers, where negative answers were permissible, you can't have dimensions that are negative. The width of a bedroom can only be positive. So the width of negative 12, even though the algebra gives it to me, it's not feasible and it shouldn't be included in my answer. I can't say the width of my bedroom is negative 12 feet or whatever the units are. So my answer, I'm just going to write words as opposed to a sentence, even though I like sentences. The width is going to be 9 feet. The length, I'm going to add 3 to it. The length is going to be the width plus 3. So it's going to be 9 plus 3, or 12 feet, going off the screen. Let me make sure that this makes sense. Does the area of that 9 by 12 bedroom does that equal 108? Yeah. So my answer feels good. One more rectangle problem. And then we have some triangle problems. So let me see if I can push through number 14. The width W of a rectangular bedroom equals 3 feet less than its length. Less than is a subtraction. That we switch the order. So the word less than gives me a subtraction. The 3, the number that comes before the less than, is going to go after the subtraction, and the its length is going to go before. Its length is going to be there. So for this problem, my W is the width of the garden. L is the length of the garden. And from the first sentence, I get W as L minus 3. Second sentence says the garden has an area, A, of 54 feet. It doesn't say is, but I'm assuming that of is like an is. So I'm going to say the second sentence says the area is 54, even though I used a different word. This is a problem. Sometimes when problems are written, they're not written with algebra students in mind, and you have to start just understanding without the keywords how to create a equation. So again, I can't use the A because it doesn't have the variables that I need, and I know that area is length times width. Now I'm going to change the W to length minus 3 and get length times length minus 3 equals 54. Clear the parentheses, do L times L and get L squared. L times minus 3 and get minus 3L. Set it equal to 0. Get it ready for sight factoring by creating a couple of parentheses that the L leads off. and then hunt around. 54 is on my sheet. I need the plus minus factors of 54, smaller number plus. So for 54, it's got to be on here somewhere. 54, I would either, for negative 54, smaller number plus would be 1 and negative 54, 2 and negative 27, 3 and negative 18, 6 and negative 9. I need the pair to add up to negative 3. So the pair I'm going to need is 6 plus negative 9, because not only do those multiply to the negative 54, do they add to the negative 3. So one of my parentheses will get a plus 6, the other will get a minus 9. Sight solve, the first one I would get a negative 6 for my length, the second one I would get a 9 for my length. Just like the negative width wasn't feasible, a negative length isn't feasible. So my answer, the length has to be 9, the dimensions are feet. And then the width is length minus 3. So the width is the length 9 minus 3, or 6 feet. And that makes sense, because if I multiply the 9 and the 6, I get an area of 54, and the width is 3 less than the length. So that feels good. Now, triangle problems, and I need to know some dimensions of a triangle. This one doesn't really have a formula per se, but I need to know some of the features of a triangle. So if I make just a generic triangle, usually in a geometry class, you'll see a line drawn from one of the vertices or one of the corners marked with a little right angle. That's called the height. The distance between one of the corners and the side opposite is called the height. And the height, we usually give the variable h, and the side of the triangle that the height intersects, we call the base. So I need that bit of information for problems 17 and 18. I don't need any formulas per se, but I need to know what the height and the base of a triangle are visually. So as I read through problem 18, it says the height, h, of a triangle is 3 feet shorter than the base. So 3 feet shorter than the base, that's going to be 3 less than the base. That's going to be base minus 3. Done with the first sentence. Second sentence, oh, that gives me something more. I need more than just this diagram. I need an area formula for a triangle, which I didn't put on this sheet. So I know that in order to get further, I'm going to get the area of my triangle. A is 20 square feet. So the first sentence gives me the height is the base minus 3. The second sentence gives me the area is 20 feet. Unfortunately, this isn't very good, because I don't know how to solve that without having more information. Just like I needed the area as length times width for the rectangle, I need an area formula for a triangle. Neglected to sneak that on here. There's a couple ways to write the area formula for a triangle. It's either base times the height over 2, or it's half the base times the height. Those are equal to each other. They're both equally bad. debating right now which one to use, because I usually teach this problem in intermediate algebra, and we do stuff with fractions in intermediate algebra that we don't in our class. So I need to really think on the fly here. So I'm going to use the half the base times the height. And then I'm going to teach you some math that you need to know anyways. They don't have you learn everything that you need for college algebra, and this is something that's going to be important. So now I transformed my area equation so that it will handle this b minus 3. So I'm going to change to half the base times the height, which is half of b times b minus 3 equals 20. And now I'm going to do something to get rid of the fractions. I'm going to multiply both sides of the equation by 2, or equivalently 2 over 1. On the left-hand side, if you multiply reciprocals, those will equal 1. So I can make the left-hand side just have the b times b minus 3 if I'm willing to multiply the right side by 2. Sorry, this is kind of a clunky lecture on this problem, but it kind of is what it is. Hopefully it wasn't so horrible for you. That part should make sense, that the height is 3 feet shorter than the base. Shorter, there's a minus word, a new minus word that switches the order. Area is 20, that should be a freebie. That we didn't know, but I threw that in here. And then the substituting is the same, but the solving part is different. Let me clear the parentheses and get b squared minus 3b equals 40, and then minus 40 minus 40, and get b squared minus 3b minus 40 equals to 0. I want to sight factor this. I'm going to put a couple of b's in front of my parentheses. And for the minus 40, I need the factors smaller number plus, bigger number minus. So 1 and negative 40, 2 and negative 20, 4 and negative 10, and 5 and negative 8. And I need to pair that when I add them, I get negative 3. And that's going to be the 5 and negative 8. So in my parentheses, I'm going to get a 5 and a negative 8. I'm going to sight solve. The first b plus 5 is going to give me an answer of negative 5. The second b minus 8 is going to give me an answer of positive 8. The base of a triangle, it's a physical dimension. Physical dimensions can't be negative, so underneath the negative 5, I'm going to say it's not feasible. So my answer, the base of my triangle, is going to be 8, and the units are in feet because I see the word feet there. So the base is going to be 8 feet. And then the height is the base minus 3. So the height is going to be 8 minus 3, or it's going to be 5 feet. Let me show you that this works. To find the area, it's half times the base times the height. The base times the height would be 8 times 5, which is 40. Half of 40 is 20. So this works as well as it can work. The next few problems that we need to do, I'll put in a new video because it has to do with the a squared plus b squared equals c squared Pythagorean theorem, and I want to keep those separate from these area problems.